I'm kind of rushing through this part because we want to get to the labs very quickly. But we are very, very pleased to have Jennifer Lin be a keynote speaker for us. So Jennifer was a co-founder of Contrail Systems that was acquired by Juniper. So she runs product management for cloud services at Juniper today. And if you look around about, she speaks in a lot of industry events, and she's a visionary. So she's going to be giving you a overview of her view of the world, working with customers with the Contrail products, the virtual router products, which are relevant to these kind of NICs in the market. Okay. So with that, let me hand over to Jennifer Lin. Thank you.
Good morning, everyone, and thanks for having me here. I know we only have a few minutes. I wanted to give a little bit of insight from what we're seeing in the marketplace. And as you heard, we were acquired by Juniper Networks. We were a software startup, 50 engineers or so, purely focused on delivering new network services in cloud environments. And so I'm going to talk a little bit about what that means. But my history personally, I spent some time at Intel, obviously very focused on looking at how we sort of mass produce chips and scale that up and sort of meet the mass market demand. That now, obviously, a lot of the cloud providers are building data centers with 200,000 servers at a time, and the expectation that they have on the software is obviously quite different, but that creates a closed loop back to hardware. So while I focus on software-defined networking and we have an open source software product, a lot of this is really about the ecosystem moving forward in new ways. This is just an example. I mean, we're seeing a lot of changes in what our customers are doing in software to essentially hide a lot of the complexity, but more importantly for a lot of the web scale companies, they're doing a lot of highly distributed software applications that are very much customized to what their applications and users are doing in real time. So that closed feedback loop in software obviously dictates some new use cases. And when we founded Contrail, we had very deep expertise in networking, routing, switching, and wireless controllers. I had worked with a good set of the team at Cisco, building out software forwarding paths in the ISR, which is essentially an enterprise router, branch router. And now if you look at use cases, one of the key use cases in telco and network function virtualization is the new branch access scenario where you have a cloud controller and very simple devices out at the edge. What we're doing in the data center is actually quite simple. We're trying to, or quite similar, we're trying to put a system-level automation and orchestration layer on top of commodity x86 server environments. But because we're doing a lot of distributed applications, the edge is being redefined. And when we say the edge, that could be the network edge, or in your case, if you're looking at what we're doing in the NICs, the expectations of what we're doing at the host level is actually quite different from what we've done in the past. So from our perspective, we look at the market in sort of three areas. One, and the key market segment that was our beachhead segment, where we really cut our teeth in kind of these new models, was the SaaS and emerging markets. A lot of these folks are building three-tier web applications. We're working with a lot of gaming and entertainment companies that have primarily container-based software technologies. They expect a lot of context in the way that they're doing forwarding in the network. And there is a lot of intelligence in the software layer that wasn't necessarily there before. We're also helping a lot of traditional enterprises move from a traditional VLAN-centric network segmentation model to more of a network virtualization and software-defined model. And that is not just about, how do you forward packets quickly. A lot of that is about how do you define the network at a higher layer of abstraction so that you can essentially do more intelligent services without a lot of the overhead that we need per packet. And then finally, we had announcements with AT&T, Orange Business Services in France, and NTT in Japan. They're all using our product right now in their transition to take the best of what cloud computing can do and introduce new models for managed services. So I'll talk a little bit more about each of those. Fundamentally, everybody knows what cloud is, but it's very different from virtualization and server virtualization. When we were doing our Series A funding as a startup, our lead investor was Vinod Khosla, one of the founders of Sun Microsystems. If you look at what is going around with Docker containers and a lot of the hype, we've done Linux containers for some time, and virtualization similarly is nothing new. We've done network virtualization for 2 decades now with IPVPNs in the wide area network. So if you think of IPVPNs as the first example of a network overlay, essentially what that was able to do was define a virtual network that was not tied to a physical construct, but could be attached to a security and network policy. And that happens to be the most profitable business for our carrier customers today. They manage the IP networks and security on behalf of their large enterprise customers like the large banks and the large enterprise companies. And they basically can outsource the management of the IP network, but essentially the control of how those policies are defined are retained by the enterprise customer. So they hold the carriers accountable for a service level agreement, and they pay them on an annual basis, but they retain all the control in terms of how those security policies, network policies, who can talk to whom and how are defined, right? There was a similar problem in cloud where essentially you had multiple tenants in a cloud. Think AWS, VPC, or Amazon or Google Cloud, where essentially now you need to ensure that you keep tenant isolation between various customers, and you never know what kind of capacity you're going to need to present. So we look at that as a very similar model, and what Contrail was focused on doing was take the best practices of how we achieve access control and secure multi-tenancy into essentially a virtualized data center environment. We're now sort of connecting hybrid clouds in various scenarios. We just did a keynote at KubeCon, the Kubernetes conference up in San Francisco. One of our customers is essentially doing all of their deployment or development in AWS, but they're building out private clouds in their own data centers. And the expectation is that they have full workload portability between the public cloud and the private cloud. And that's what they're achieving. We're obviously providing the network layer and a lot of the policy engine for the network automation. You know about network virtualization, so I don't have to describe it, but the problem, which is a new problem, is that in every single host, you may now have 50 virtual networks. 50 different policies needing to be attached to virtual machines and containers that are co-located in a host. And because you now have real-time compute schedulers, think of what Google's doing with Borg and Omega, what Kubernetes is doing with cluster management, what Mesosphere is doing with their DCOS. The expectation is that the infrastructure capacity is spun up on demand when the workload needs it. So you don't schedule the capacity for workload until that sort of infrastructure is needed. The infrastructure as a service model essentially serves the platform or application SaaS layers. So that is sort of the problem that we were going after in terms of the software layer. How do we make this very simple, hide a lot of the complexity is what's going on, but more importantly, distribute a lot of these network services down to the host layer. So the virtual view and the logical view is that I need to connect 2 virtual networks, virtual network green and virtual network yellow, all service, or virtual network blue. All flows need to essentially go through some firewall service or a load balancing service, and those services are presented as a service. So the policy is defined independent of the vendor technology. I can replace, let's say, a checkpoint firewall or a Juniper firewall or a Fortinet firewall, and that policy, that rule, never changes. The configuration and the individual parameters for that instantiation of the service may change, but the policy never changes. So you hear a lot about, we co-authored the group-based policy blueprint in OpenStack. A lot of the networking players are not used to this model of defining a policy which is vendor agnostic and not tied to a device-level CLI command. This is the way, by the way, all the web services guys already do it. So one of our other Contrail co-founders came from Google. He was working on the Google controllers and doing cluster management software in their data centers. But he also, prior to that, was leading the L3 VPN working group in the IETF. So thinking about how do we essentially do distributed routing and secure IPVPN technology in a way that solves this new problem, which is how do we automate these things with very simple abstractions, a virtual network, use the concept of a label, which we've used in MPLS VPNs for a long time, so that we're not doing flow-by-flow sort of inspection every time, but we do a very simple lookup with a 20-bit label, and we can identify which virtual network this belongs to and enforce the policy in a very efficient way. A lot of it, though, from an operational perspective, if you look at the way the DevOps teams sort of manage these large-scale environments, they need a lot of telemetry and a lot of very granular monitoring capabilities. So in our case, we do sit in the host. We have a Linux kernel module with the vRouter. Think of the vRouter like OVS, except for it does distributed L2 and L3 services. A lot of the sort of monitoring information that the network folks in the data center were missing was, how do I look at the 5-tuple flow statistics for every virtual machine? And then how do I quickly aggregate that against the time series database so I can see the aggregate flow statistics for virtual network database, as an example. A lot of these things are the way that the web scale guys are doing it already. Really what we were doing was trying to take some of those best practices and make it consumable for folks that couldn't hire teams of folks like Google and Facebook are already doing. So I've talked a lot about this. The abstractions in terms of the encapsulation, as well as the control plane, as well as the northbound APIs are what make this sort of very simple. There's a lot of complexity hidden in there. But whether it's virtual machines on ESXi or KVM or Xen or a container, or hooking in bare metal servers into a network policy, we've now put into production all of those scenarios with the same architecture. And a lot of those challenges, I mean, obviously, folks like VMware have had 2 decades of mapping services onto the ESXi environment and using vCenter as the orchestration layer. And then there were new types of orchestration models like OpenStack or CloudStack or Mesosphere or Kubernetes. So how do you build a horizontal platform architecture that stands the test of time? When IP networks were defined, IP was defined as the ultimate abstraction between the physical media, whether it was optical or Ethernet or whatever, and the application on top. Nobody knew that Facebook was going to be the killer app. But essentially, that IP abstraction layer has sort of held the test of time. And it's not just about the forwarding. Obviously, a lot of where we've focused has been in sort of how do we build a scale-out control plane. And that control plane is based on BGP. BGP, obviously, is the most pervasive control plane out there in the internet and secure IP networks. That problem in terms of how do you get the benefits of horizontal scaling and be able to essentially do a unified control plane, not only across clusters within a data center, but also across data centers or across public and private clouds. I'm not going to go into the architecture, but there are some components. Most importantly, in the host layer, think of the vRouter as a replacement for the Linux bridge, or OVS. The key difference between what we're doing with the vRouter and OVS is that we do have a fib at the compute node level, so we can do a local lookup. So we've built essentially a routing table within the vRouter that essentially allows us to route directly from one workload in a host to another. And that's the reason why some of the gaming companies, we're working with one of the largest gaming companies, they're deploying Contrail in production. They've already deployed it in some of their data centers. They looked at all the alternatives, and they chose Contrail for 2 major reasons. One, because of the efficiency with the vRouter, but number 2, because of the ability to do service delivery at the host. We open sourced all of our code when we went GA. All of our OpenContrail stuff is on GitHub, and that has also been not only good for source code transparency and working with our partners and customers in a very sort of agile and transparent way, but most importantly, it's allowed us to play into the ecosystem where most of the web scale folks are using a high degree of open source technologies already in the data center, except for generally the network piece. So the network piece was the last piece. If you look at a lot of these data center environments where the open source model of software delivery was not really pervasive yet. That's obviously changed quite a bit in the last couple of years. A lot of efforts to open source a lot of the network technologies. Facebook did a white paper on kind of how they're running their data centers. And the key thing here is that their switching architecture is very different from what you'll see in pretty much all the legacy enterprise telecom carrier environments. And one of the key reasons is that they bring native routing all the way further into the Tor or into the host, because most of their workloads are east-west. So previously, in normal client-server enterprise applications, most of the workloads stayed within a VLAN. So the issues around sort of crossing the layer 3 boundary did not come up a lot. Here, you need to do essentially a routed sort of forwarding model pretty much for every transaction. So when you go to Amazon.com and it says, welcome back, Jennifer, this is what you bought last time, and we're going to fulfill your item from this data center, That's probably hundreds of transactions in parallel at the same time, all from very distributed computing workloads coming back and being presented in my web page. We do a lot of distributed services in the vRouter, which is why we couldn't use some of the existing kernel modules doing packet forwarding. Things like NAT and multicast and QoS marking, things like policy enforcement and distributed firewalling. We have essentially a stateful firewall in the vRouter. And the key thing about that is that tenant isolation at the host level is not being done by OVS today. If you look at Kubernetes and some of the stuff that's going on with Docker, the key reason people are very concerned is because they can't sustain tenant isolation with very dynamic workloads. So there's a lot of folks doing various projects to address this problem. It's something, obviously, we've had from the beginning, but it translates very nicely to new types of workloads. Just a couple of snapshots of what our customers are doing with the technology. Probably one of the first OpenStack production environments was a company called CloudWatt that has since been acquired by Orange Business Services. They went live with an OpenStack-based public cloud and used Contrail for the network virtualization and service chaining aspects. We've been public about some of our SaaS customers like Workday and Symantec. In this case, Symantec is a SaaS provider. They do threat defense and IPS security services as a SaaS. But they presented at the Hadoop conference, and they talked a lot about the analytics that they're doing with Hadoop and Spark and Storm and Kafka, et cetera. They have like 6 petabytes of data already, and what they're processing in terms of real-time analytics puts a lot to load on sort of a very dynamic scale-out infrastructure. So we've learned a lot of lessons there. They've actually contributed back a lot of the test plans and upgrade processes, et cetera, that they've learned in operating their own virtual private cloud environment. But this migration challenge is also, from a network perspective, our job is to interconnect domains. It's not to say there's one technology that sort of wins out on everything. And we've seen this again and again. When IP networks became pervasive, the problem they were trying to solve is you had AppleTalk and DetNet and sort of SNA and various proprietary LANs, and you needed one network architecture that needed to be interconnected. It's a similar thing in this cloud migration. So every one of our financial services government customers has a lot of legacy. Still mainframe technologies, a lot of bare metal servers, a lot of physical appliances, virtualized appliances. And in the meantime, they're trying to figure out how to manage their clusters that have a combination of vCenter and OpenStack and CloudStack and Mesosphere. And how do you do that? So that's why this abstraction is very important. All of our customers, if you take someone like NTT, they've got all of the above in their environment. They're a multi-billion-dollar company. They're using essentially a common network architecture, and they're using it to essentially upsell what they're already doing in private IP network delivery with essentially this cloud layer. And for us, the cloud networks are really just how do we present the network services to the application layer in a way that hides a lot of the complexity. Because the frustration that a lot of folks have, and if you look at GE, they're now saying 60% of their corporate workloads are in AWS. They didn't necessarily plan it that way, but the developers moved quickly to that environment because it's just easy to self-provision an environment and essentially have all the services there for you in a dashboard. So that's what a lot of folks are doing now as they're building out their private clouds. But the expectation is that they can federate what they have in their own data centers to what's services that are very similar in AWS VPC as an example. So that example that I talked about before, one of our social networking customers can move those workloads from AWS to their on-premise cloud without changing any of the provisioning scripts or automation scripts. So to the developers, essentially, they're served up a cloud, and the developers don't really care which data center or which network or which appliances it's hooked into. That's for the infrastructure team to manage. Some of the other use cases, we're working a lot with the tier 1 carriers, and what they care about are how do we do this for very sort of small packet size, low latency type mobility apps? If you look at someone like an AT&T or NTT, the most profitable business that's emerging for them are the mobile data center mobility services. And so we've done a lot of work with virtualized MMEs and how do we essentially take a lot of the mobile packet core, transition to 5G. Those types of virtualized services look very different from the 3-tier web applications. A lot of the work we're doing is around DPDK optimizations, SRIOV coexistence with the vRouter. How do we essentially make sure that we're being very efficient in in these types of applications, which look very different. They're generally stateful applications, not stateless applications. They're very, latency sensitive, and they're very bursty. And then finally, we've got what I mentioned before, this emerging use case of virtualized customer premise equipment or branch access. We think of this, so we have several customers running the vRouter on a low-cost CPE device. Essentially, when they plug in that CPE device, it calls home to the controller, it sucks down its configuration, and all the services are provisioned with zero touch. That model is very similar to thousands of data centers in a data center, thousands of servers in a data center where it calls the controller, understands its configuration, and essentially enforces policies. The only delta is now the data plane is going over the wide area network. So it may be IPsec, it may be TLS, it may be SSL, but that sort of encrypted tunnel is probably the major difference in terms of how that data plane is served up. So I know I speak fast and that covered a lot. I just wanted to share a little bit of what we're seeing in the emerging use cases. It's been really important to us as an overlay technology to not reinvent how the physical network does its job really well in terms of building secure, resilient IP networks, but more use this software layer to address the new problem. So we've shown interoperability with our overlay with essentially, obviously, Juniper routers and switches, Cisco, ALU, Huawei, anyone where already what they're doing is terminating secure IP networks. So hopefully that helped, and thanks for having me here today.